His research has been widely published in high-impact journals with the more than 30 research papers in SCI and Scopus Index journals. Uh, Welcome to Dr. Surjeet Kumar Chobe.
Thank you.
Yes, over to you, sir.
Okay. Good evening, organizing committee members and fellow participants. It's a great honor to be here today for this important faculty development program on emerging trends in additive manufacturing of advanced materials for industrial applications. And I would like to express my sincere thanks to Dr. Gurvesh Singh to invite me as a guest, as a speaker for this session. My name is Dr. Surjeet Kumar Chobe, and I am currently doing postdoc from University of Johannesburg, and my area of expertise in advanced manufacturing, gear engineering, and gear metrology. So this FDP provide a wonderful opportunity to understand the theoretical foundation of additive manufacturing as well as its practical applications. So today I'm going to present my topic on the multi-materials and hybrid additive manufacturing process. My slide is visible, sir?
Yes, very clear, visible, sir.
Very much visible, sir. Good evening.
Okay. So summary of presentation is foundation of additive manufacturing, including introduction and review, types of additive manufacturing, key terms and materials for additive manufacturing, applications, and introduction of multi-material additive manufacturing, and introduction to hybrid additive manufacturing, and its advantage and applications, materials used in multi-materials additive manufacturing and hybrid additive manufacturing, and comparison between both, and conclusion and future research directions. Manufacturing is a process which is used to convert raw materials into finished goods. And manufacturing has a different type, such as a discrete manufacturing, process manufacturing, repetitive manufacturing, and batch manufacturing. Discrete manufacturing indicate the manufacturing of a distinct product, like a specific product such as a car and other things. Process manufacturing is indicate the manufacturing of some goods, process. And repeated manufacturing indicate the manufacturing of a same product, and batch manufacturing indicate the manufacturing of product in a group. So manufacturing, there are various types of manufacturing process used to convert raw material into finished goods. These processes are subtractive process, in which
Dr. Surjeet, sorry to interrupt. Your slide is not visible. Please check once.
now it's visible, sir?
Yes.
Subtractive process in which materials removed in the form of heat to convert finished products. Another is a formative process. Formative process is a metal deposition process in which material is deposited to form a finished goods. And another is a deformative process in which product are manufactured with the help of permanent deformation of the product. So the subtractive process like milling, drilling, And formative processes are in casting, injection molding, powder metallurgy. These processes are the formative process in which the metal deposition take place. And the deformative process like extrusion, forging, stand forging is this type of process are formative process. So this machining process has some limitations, such as it's left tool marks on the machine parts. And another thing is it's limited to design flexibility. Complex design cannot be difficult to manufacture by machining process. And another is required the secondary finishing process. And there is a and in machining process there is a vibration. So overcome to these problems, nowadays researchers focus on the another alternative manufacturing process that is known as additive manufacturing process. So you can see this different type of process, manufacturing process. First, for the subtractive process in which material is removed in form of chip. Second is a material deposition process, and third is a plastic deformation. This is known as a deformative process. So you can easily understand with the help of this slide animations. Additive manufacturing is also known as a 3D printing, but 3D printing is a part of additive manufacturing process. This is a step which involving additive manufacturing process. And additive manufacturing, as a additive indicate, that is additive means a substance that is added to something in small amount for a special purpose. So in additive manufacturing process, refer to a group of manufacturing process where materials are added, deposited by layer to build a object from a digital model with the help of digital models. So models. This technology, what is the main benefits of this process? It can build any type of objects, and it eliminates the constraint imposed by the conventional manufacturing process. AM refers to, unlike traditional subtractive manufacturing, additive builds object by adding materials, often precise and intricate layers. AM is widely used to manufacture a 3D object by layer based materials based on the digital models. As you can see in the figure, they create the object with the layer by layer depositions. And AM can use a variety of materials like plastics, metals, and also resin can use for as a materials. The process begin with the 3D model and create using CAD software, and then after that it is sliced into the layers to guide the machine in building each layers. Key characteristics of additive manufacturing is layer by layer depositions and customization of products. So we can manufacture a variety of objects through the additive manufacturing process. And materials versatility. So a wide range of material can be used for manufacturing the object through additive manufacturing. And major benefit of AM is the ability to rapid production of prototypes, enabling fast iteration in design and product development. So this is the basic introduction of additive manufacturing. So this is the animation of additive manufacturing. We show the manufacturing of a human face by layer deposition. And additive manufacturing begin with the bottom to tops. Is first create the base, then is starting with the bottom, then end with the tops. So, there is a additive manufacturing. There is a metal deposition process similar to the casting, but there is a slight difference between the castings and additive manufacturing. You can see that very complex product can be manufactured by this additive manufacturing process. Such a human organ can be also trying to manufacture these products. Gears can be manufactured, and another complex product can be manufactured by this process. So in both are similar, casting and formative process and this process. One major difference is that in additive manufacturing, there is a layer by layer deposition. Means products can be manufactured in multiple steps, but in casting process, injection molding process, powder metallurgy, material can be product can be manufactured in a single step. So we can say in this figure that this student inject the material into this mold and it's in single step. But in additive manufacturing, product can be manufactured by layer difference. This is a major difference between the formative process and additive manufacturing process. This shows the slight difference between the conventional and additive manufacturing. So for conventional machining process, so we need a blank to manufacture some product like turbine blade and impellers, which involve the first creation of the blank, then machining, which involve the different type of machining like drilling, milling, and then a product will be created. So there is a lot of scrap, material removed from the workpiece. But in additive manufacturing, there's a whole product manufactured on single platforms. So there's a less inventory, and also material waste is very less as compared to conventional machining process. So now the classification of additive manufacturing process. So additive manufacturing processes are basically classified into 7 categories according to their nature of process. First is material extrusion process. This process involves continuous depositing of material in specific pattern to build a object, typically using a heated nozzle. So a filament pellet is used, and as a paste is used as a materials. So materials are thermoplastic and composite materials, and techniques known as a fused deposition modeling and fused filament fabrications. Another is a wet polymerization. This is the alternative of the material extrusion process. This involves the curing liquid resin under light, UV light, lasers, layer by layer to form a objects. And this is manufacturing processes are stereolithography, digital light processing, mark stereolithography, and this is suitable for photopolymer resins only. And another is about powder bed fusion. Powder fusion, this process uses a heat source to fuse the powder particles layer by layer to build an object. And it is suitable for the metals as well as polymer and ceramics. And processes are selective laser sintering, selective laser melting, and electron beam melting. Next is binder jetting. Binder jetting, a liquid binder is deposited onto a powder bed, binding it together. The object is then processed to harden, and this process is suitable for metals, ceramics, as well as polymers. And processes are sand binder jetting and metal binder jetting. Another is material jetting. This process jets tiny droplets of materials, and which then cured by the UV light, treated by UV lights, other methods like laser to form the object. And suitable material is photopolymers, wax, and metals, sometimes metals. And processes are polyjet, multijet modeling. And next is sheet lamination. This method bonds materials, which is in form of sheets and then layers with heat of with the addition of heat, adhesive. And after heat, after lamination, then it cuts into the shape using laser, mechanical tools, mechanical machining process. And this process is suitable for paper, metals, plastic, and ceramics. And processes are laminated object manufacturing, ultrasonic additive manufacturing. And last one is a direct energy deposition process. in this process, focus energy source like laser, electron beam melts and deposit materials onto the part, often used for the repair, adding features. So repair can also be done with the help of this process, and is suitable for this process is mainly suitable for the metals and copper deposits. And processes are laser metal deposition, electron beam editing, and manufacturing EBM. This was the same thing. So out of these processes, more material extrusion processes are frequently used for for additive manufacturing. And three type of material used in three type of form. First, as a filament, as shown in figure. So filament is used, a fine wire is used to, which is melt and passes through the nozzle for the layer by layer deposition to form the object. So second is material is used as a gel, liquid, and a plunge force it through the nozzle for the layer by layer deposition of the objects. And third is pellets is used, small grains are used, which is passing through the hooper and extrude, then leading through the extruder and heated and melt through the and passing through the nozzle to deposited on the surface layer by layer to form the object. So three types of form of material used. First is a filament, second is a paste, third is a grains, pellets. Next is a steps involving additive manufacturing process. So there's several steps involved in metal additive manufacturing process. First step is design. Here you can there's a flow diagram and also the pictorial view of the steps involved in the additive manufacturing process. So first is design stage. So this process beginning with the creating a digital 3D models of the object to be manufactured. This typically done using CAD software, other 3D software to capture a object. And next stage is file preparation, slicing. So this is also known as the preparation phase. In this phase, the 3D model is then converted into machine-readable instructions, G code, and guide the 3D printer during the build process. This step is essential for translating the 3D model into the layers and generating the proper tool paths. And another step is material preparations, and printing. So this after this slicing and then is transformed to the machine to form the object by layer deposition. After for manufacturing of the 3D object, next process is post processing, because the major disadvantages of additive manufacturing is a poor finishing, because there is a layer by layer deposition. So post finishing process is required for this process. So after post processing, next step is inspections. So after for the quality improvement, once the part is fully printed and processed, it undergoes after post finishing, it undergoes quality check for ensure that it meets the necessary standards for function and appearance. And after that, final is quality check is for the use. You can see here. This is a 3D model of the object, and then it goes for the second step preparation for slicing the layer, and also after slicing is good for the tool slicing the layers and tool pass. It means every manufacturing process has a certain variable parameters, so it's necessary to give the value of the variable parameters. So, and after that is printing, and then 3D objects. So this shows the various steps involved in additive manufacturing process. So next is key process parameter responses and additive manufacturing in additive manufacturing. So every manufacturing process has a certain variable parameters, and these parameters significantly affect the performance of that process. So similarly, additive manufacturing process have also a certain variable parameters, and suitable selection of these parameters is necessary to improve the performance and get the better surface quality and dimensional accuracy of the object. The three process parameter are printing speed, the rate at which material is deposited, and next is layer thickness, thickness of the each layer. Material flow rate. Material flow rate indicates the amount of material deposited over the time. And laser power in case of using laser. Beam sport size in case of electron beam machining. And printing temperatures is another important key process parameter. And next is build platform temperature. Like FDM and SCA, the temperature of the printed bed can significantly affect the adhesion. And infill density and pattern controls the internal structure of the part, which affect both mechanical and properties and material uses. And next is post-processing parameters. These may include curing time, temperatures, cooling rates, and additional treatment steps like sintering. And overhang angle, a key factor for support structure. So after designing and slicing, there is need to give the analyze there is a requirement of a structure, additional structure or not. So overhang angle is a key factor to support structure. Certain angle are difficult to print without additional supports. And key responses of surface quality. So it indicates the overall quality of the product and its appearance as well as surface pattern. Dimensional accuracies, mechanical properties such as tensile strength, hardness, fatigue resistance, impact, strength, porosity. Porosity is a basic problem in as well as casting as well as additive manufacturing, wrapping and distortion. Print the time, productivity is also important parameters. It indicates the performance of the additive manufacturing, material utilizations, and part orientation support requirements, bonding strengths. These are some key responses, output of the additive manufacturing process. A specific response for certain additive manufacturing processes such as FDM, FFA, layer bonding, print speed, extrusion, temperature, and wrapping is the process parameters. And responses are surface finish, which can be rough depending upon layer height and extrusion rate. So it is necessary to control printing speed and layer thickness to get the better finished object. And for stereolithography, resin wearing, layer thickness, support, structure efficiency are the key input parameter. Surface finish, accuracy, part shrinkage are the output parameters. So these are the some input parameters and output parameters of particular additive manufacturing processes. So next is the advantages of additive manufacturing.
Sir, please mute yourself. Kushdeep Rana, please. Yes, sir, continue.
So additive manufacturing offers significant benefits, which is like the first is a complex geometry and customization. So with the help of additive manufacturing, complex object can be easily manufactured, and variety of object can be manufactured with the help of minimum material waste. So you can see that the complex structure manufactured by additive manufacturing, and such as turbine blades and bone implants can be also manufactured with the help of additive manufacturing. And minimum material waste. So in additive manufacturing, the material waste is very low as compared to conventional. Lower tooling cost because all processes are happen in a single platform. So there is a less tooling as compared to conventional, and rapid prototyping and faster time to market. And next is cost effective for low volume production. So additive manufacturing is best suitable for the low volume productions, and there's a design flexibility. So all kind of object can be manufactured with the help of additive manufacturing. We need to just design it and transfer to the printing. And another benefit is on-demand production is possible. So and with the help of additive manufacturing process, repair can be possible of worn out products. And also it reduces the inventory. And in this process, there is a less tool as compared to conventional process, and it enhances the product performance. And this process is sustainability also is there. So, because there is no any harmful emission machining process, so there and can be used for bearing materials, so the metals, polymers, ceramics. So it can be tools, or it can be used for a specific purpose, like this object products. And this was the repair of the blades. So all kind of the complex product can be manufactured with the help of advanced manufacturing, additive manufacturing process. Next is your application of these aerospace industries. So aerospace for any prototype parts can be manufactured, lightweight and high strength part can be manufactured with the additive manufacturing process. And in next is automotive industry. So in automotive industry, they use for the prototyping and testing for making spare parts and customized parts. Third is health and medical care. So additive manufacturing are used for the making bone implants, knee joints, and also drug delivery systems and making drugs and capsules by the additive manufacturing. And another is construction. Nowadays, additive manufacturing is also used for making for the construction work. Large scale 3D printing is used to build house, bridge, and other structure more quickly compared to other process. And it's also possible to make the complex geometries. And another is consumer goods. So it is also used to make consumer goods like shoes and mobile covers like that. And it is widely used in electronics and communication industries, designing custom circuit boards and enclosure with the specific sharp and feature for better integration. Another is educational research. So in educational additive manufacturing, I use to particular specific model for teaching and educational fields. It's also used for art and design industries. This is also used in fashion apparel industry. So creating unique customized clothing, footwear, and accessories. Fashion designers use 3D printer to push boundaries with textures and designs. Next, it's also used to in food and food production industries. So development of new food textures and presentation, as well as the customized dietary needs by printing integration in intricate forms. And next is the energy industries. So it is used for making parts of various solar energy system and wind turbine components. These are some specific area of application of additive manufacturers. So Despite of many benefits, additive manufacturing has some limitation and drawback. These limitations are materials limitations. So, in additive manufacturing, there is a material limitation. So, like conventional machining process, in additive manufacturing, there is a limited material varieties, and other is a variation in material properties. So, in material property, strength of object depend upon the direction of material depositions. So, it affects the material properties. And another is a higher material cost. So, for additive manufacturing, we need a wire, filament, and other powders of the metal like titanium. So it increases the cost of materials. Another is speed and scalability. So additive manufacturing is a slow process as compared to conventional process, and also it is not suitable for the mass production. So it is best suitable for the prototyping and small batch productions. And also surface finish, poor, it gives the poor surface finish. And another disadvantage is it's required the post processing requirements like time. This is post processing is lead the total manufacturing time as well. It increase the cost. And another disadvantage is structural integrity and performance. So you know that is weaker parts anisotropic properties means due to multi-directions of the material depositions, size and build volume constraint, limited build size, and size constraint for large parts. So you can see this for large, if you want to produce large parts, then you need a larger platform. So this increase the cost of the initial cost of the additive manufacture. And operational cost is high. Design complexity, lack of standardizations, quality control and consistency, environment impact because energy consumption is high in additive manufacturing process, and other intellectual property and cyber security such as data securities and IP protections, because initial stage of this process is design and slicing of the object. These are some limitations and challenges. So that you can see that this is a product manufactured by the additive manufacturing. So after post finishing, we will get the desired finish of the product. So we can easily, and this is so the desired shape. But after manufacturing, we will get the actual shape of the object after printing is this, and so we need post processing to get the desired shape. And so material used in additive manufacturing process there are variety of material used. Composite materials are used, bio ink, composite materials, bio inks materials. Easily composite material, bio ink, ceramics, metals, photopolymers, sand and powder materials, and non-metals are plastics such as PLA, ABS, nylon. And metals are aluminum, stainless steel, colon, cobalt, chromium, titanium. Ceramics are aluminum, zirconia, silica can be used. And these materials are available in the form of powder, pellets, tape, filament, seed, and liquid. So for additive manufacturing processes, these materials are available in this form. You can see that it is through the materials form. So powder is basically used for laser powder fusions, thermal powder bed fusions, and pellet is used in extrusion process, and filament is also used in extrusion material extrusion process, and liquid base material is used in bed polymerization, or resin are used, material jetting, thermoset deposition process, and continuous fiber thermal deposition process. So these processes requires liquid metals, and the powder is required for laser powder-based fusion systems. Next slide is multi-material additive manufacturing process. Multi-material is similar to the additive manufacturing process that allows the creation of object using multiple material in a single print. So sometimes we need to enhance the object of the material properties. So we just perform a coating on that object to increase the corrosion resistance as well as the wear resistance. So it is done by conventional methods like the surface coating, CVD and PVD. So it increases the total lead time. But in multi-material additive manufacturing process, this can be performed in single platforms. So multi-material additive manufacturing combine materials with distinct properties such as in strength in one object, unlike traditional 3D printing with a single materials. So multi-materials additive is crucial for industry like aerospace, automotive, medical devices, and electronics and consumer goods that require specialized parts. And it enables the creation of complex multifunctional parts, offering exciting innovation opportunity across the industries. The multi-material has a potential to revolutionize the manufacturing by enabling advanced functional parts across industry like aerospace and healthcare. So you can see this object, single object. There is a multiple material manufactured by multiple materials by additive manufacturing process. This figure shows this is a copper. Then another material is deposited with the multi-material additive manufacturing process, which is used to enhance the corrosion resistance. And top of the is another materials which is used to enhance the wear resistance of this product. So all this surface coating as well as material object manufacturing can be done with the help of multi-material additive manufacturing process in single platform. So this shows for performing the multi-material additive manufacturing, we can provide multiple wire in extruder. Yeah, we can use multiple nozzle to perform the layer by layer deposition of multiple materials. So there is option we can use like previous here the 2 wire is used for the creation of object having 2 different materials. And another, we can use a different nozzle to create the different materials for deposition to create a single object. So technology used in MM is similar to the 3D printing, as I explained in earlier slides. So similar, and just we need to provide additional function for the additional materials, as discussed previous these slides. Key benefits of key characteristics of multi-materials additive manufacturing is material diversity. So it involves using different materials such as metal, plastics, ceramics, composites within the same parts. Other is a customizability. The material can be positioned in specific areas, offering customized mechanical, thermal, and electrical properties. So we can enhance the mechanical properties with the help of this process. And another is a complex geometries. So this process allows the creation of intricate design that cannot be achieved with the traditional manufacturing methods. So these are some key characteristics of multi-material additive manufacturing process. And what is the major advantages of multi-additive manufacturing process are material diversity. It uses different materials And design flexibility is there, and functional integration. It allows the printing parts from multiple material within different functions like conductor, sensor, insulator in one object. Improved performance, combining materials with specific characteristics enhances functionality like increasing strength in some areas and adding heat resistance in others. And lightweight structure, multiple material can help optimize the weight distribution, improving the part performance in application where weight is a critical factors. And the cost effectiveness, the equipment for multi-material additive can be more expensive. The ability to print a complex part in the one go and reduce material waste as a assembly cost in the long term. And time and cost efficiency, it produces complex part in one go, reducing assembly and cost limits. These are the some key benefits of multi-material additive manufacturing process. These process some challenges, such as material compatibilities. The material must be compatible in terms of bonding, printing conditions, like temperature and chemical reaction to prevent issues such as a wrapping, delamination, weak interface between the materials. Another challenge is printer complexity. Multi-material printers are generally more complex design compared to another additive manufacturing process. Advanced control systems are required to manage the multiple print heads, material fits, and layer deposition strategies. And another challenge is post-processing. Multi-material parts may require additional post-processing steps like curing, polishing, washing, especially when different materials interact during printing. And another challenge is the material cost. So high quality multi-material setups often require expensive materials, which could drive up the overall cost, increase the overall cost of the printed parts. But these are just some challenges in multi-material additive manufacturing process. And a major application of this process is aerospace. To creation of lightweight parts with various mechanical properties essential for aerospace components, where material strength to weight ratio are criticals. Another is medical devices. 3D printed implants and prostheses can be customized to integrate multiple material for different functionalities. Automotive multi-material parts help design and produce components with enhanced durability, heat resistance, and lightweight properties. For example, combining thermoplastic and thermoset material to improve the strength and heat resistance. Another is electronics. So multi-material 3D printing is used to integrate conductive materials with the non-conductive materials, enabling the creation of the functional and compact and flexible electronics components. And another is consumer products. So it offers possibility for making product like shoes, furniture, and tools with multiple textures and functionality in a single print. So these are some major benefits of multi-material additive manufacturing process. So this cannot be achieved by the other additive manufacturing process. Another is a hybrid manufacturing process. As name indicate, hybrid means is a combination of two manufacturing process. So it's a combination of additive manufacturing and conventional subtractive manufacturing process like milling, machining process. Because I explained earlier that major disadvantage of additive manufacturing is a post-finishing, post-processing process. So this process combines the post-finishing and additive manufacturing in single setup. So both deposition and metal removal process are performed on the same machine known as a hybrid additive manufacturing process. This hybrid approach allows for the benefit of both processes to utilize within a single machine systems. This integrate enable manufacturing to leverage the unique benefits of the both process. So steps involved in this process. So in this, there is a two steps involved. First is the additive manufacturing. So in additive manufacturing, object is built by the printing, 3D printings. And next step is subtracting, means after building, after creation of the object, next step is post finishing, and post finishing is also performed in the same platform, so no need to carry to another machining process. So it reduce the overall time, machining time, manufacturing times. Thus, it reduce the overall cost. So subtractive manufacturing removes the material from the solid blocks using process like kneading, grinding, or turning. It offers high precision, smooth surface, and tight tolerance. So first is the additive manufacturing. Second is the machining process. So this combination is known as hybrid manufacturing process. And here is a video you can. So this is all leveling. This shows the additive manufacturing, multi-material additive manufacturing. Basically, this is a multi-material additive manufacturing and combination with the subtractive manufacturing process. After building the object, the next process is the machining process. So you can see that the next step is machining. So all both these means additive and machining process perform on same platform. So there is reduced the tooling as well as machining setup times. So it overall reduced the total manufacturing times, and thus it reduced the cost of the printed parts. So technology used in hybrid machining process is similar to the additive manufacturing process, which is a combination of subtractive process. Some processes are laser metal deposition with milling. Another is a direct energy deposition with the machining process, fuse deposition modeling with CNC machining, and electron beam melting with post-processing. So EDBM uses electron beam to build high quality parts, which can be post-processed with the machining and grinding techniques. So post-processing grinding is used, and CNC machining is used to achieve the precise dimension and smooth surfaces. So these are the some combination of hybrid manufacturing process. And variable parameter is similar to the additive manufacturing process. Only difference is in this process, additional machining process is used. So another input parameter is a cutting speed, feed, tool geometry, and depth of cut. So these are the another additional input parameters in this process. And hybrid parameter is the interaction between the additive and subtractive process, and another is heat affected zone. A response is mechanical properties, surface qualities, geometry and dimensional accuracy, material integrity, and optimization of hybrid additive manufacturing process. So these are just some input parameter as cost parameter associated with the hybrid additive manufacturing process. And challenges in complexity and cost. So initial cost of this process is high because this is the combination of two processes. Material compatibility, limited materials selection, and material property differences, and design limitation, post-processing complexity, and process integration, speed limitations, and skill requirement. So it requires specialized training and software expertise. So key benefits of hybrid manufacturing is improved part quality. So combination of additive manufacturing or subtractive manufacturing allow to fabricate parts with complex geometry while ensuring high precision and surface qualities. Material efficiency. This process reduces material waste during construction, while subtractive process refine and enhance the final part geometry and profile of the parts. design flexibility. So hybrid additive manufacturing enables the creation of parts that are challenging to produce by individual methods. So allowing designer to optimize geometry for performance and maximum manufacturability. And cost efficiency. So all post processing and additive are performed in single platform. So it reduced the total manufacturing time as well as tooling costs. So overall cost reduce, enhance mechanical properties. So hybrid approach address material consistency in additive process such as a porosity by using machining to remove defects and improve surface finish. And these are also used in aerospace for manufacturing lightweight, high strength parts with complex geometry. And in automotive parts for manufacturing custom parts, repairing components, medical for the bone implants and nerve prosthetics and medical parts. Tool and dies industries is used hybrid additive manufacturing process. So these are some applications of the hybrid manufacturing process. And this shows a major advantage of hybrid additive manufacturing process. So major advantages is enhanced geometry and design freedom and reduced lead time, because this is a combination of post-processing means subtractive process and editing method, and superior finishing and precision due to combination of subtractive process, and it's cost effective because it reduces the tooling cost as a post-processing cost. So this is the major advantage of hybrid additive manufacturing process. So multi-material difference between the multi-material additive manufacturing and hybrid manufacturing process. First, according to criteria of process. So hybrid is a combination of two process, additive and subtractive. But multi-material is use multiple material in a single additive process, manufacturing process. Materials, hybrid manufacturing is suitable for the metals, polymers, and composite, and multi-material additive manufacturing is suitable for polymers, metals, ceramics, etc. And primary focus on precision in HIM is precision, post-processing, and complex geometry. And multi-material damage is tailored material property within one parts. And this is major benefits of multi-materials. And the main advantage is high accuracy and surface finish with complex design in hybrid additive manufacturing process. And for the multi-materials, ability to create parts with different properties in different areas. And application of hybrid manufacturing, aerospace, automotive, tooling, and medical engineering, whereas the multi-material additive manufacturing is medical devices, electronics industries, automotive, and aerospace industry. And the key benefit is a better precision and surface due to post-processing. And for the case of multi-material manufacturing, customization of part property within one print. But these are some comparison between the hybrid additive manufacturing and multi-material additive manufacturing process. Conclusion and future research direction. So in this slide, so the hybrid is ideal for part requiring high precision and fine surface finish, particularly in industry where a combination of complex steps and tight tolerance are necessary. It is a great price when both additive and subtractive capability can work together to achieve superior results. So, and from multi-material, excel when a part requires different materials properties across its structures. It allows for the integration of diverse functionalities such as rigid, flexibility, heat resistance within one component, which can be especially valuable in the industry like healthcare and electronics. And future research directions. So for the multi-material material interaction and compatibility, and printability of printability of multiple materials. So it can be manufactured by the multiple materials. So advanced multi-material printing techniques, use of advanced, another is the future research is material property controls And another research area, future research area, is monitoring of quality control during printing. So it is known as in situ monitoring and quality control. And another is a cost-effective scaling. And another measure is a sustainability and optimization, because we know that the additive manufacturing is a slow process, so optimization is necessary to enhance the productivity of the additive manufacturing process. And sustainability is to just consumption of energy to reduce the energy consumptions. And this is the some key research direction in case of hybrid additive manufacturing process. And the multi-material process is for process optimization, material development, energy efficiency, integration with other technology, industry-specific applications, and other research direction for the both process is application of AI and ML for process optimization. So these are some key future research direction. Because major research direction is improve the surface quality, because the poor surface is a major concern in additive manufacturing process. So it's researchers need to focus on the improve the surface finish as well as dimension and accuracy of the product, because poor surface and dimension are achieved because the product are manufactured by the layer by layer deposition. So anybody can easily identify the layer, because so remove that layer, we need to perform secondary finishing process. So finishing, dimensional accuracy, and sustainability and process optimization is a key research direction for the additive manufacturing process. This figure shows the miniature gear manufactured by Viridium, which I have manufactured in my postdoc duration. So here, so this is different type of gear which is manufactured by the stainless steel 304 materials. So in this process, like other process, there is no need of post finishing process. So it's manufactured in a single step by use of a single wire. And similar to additive manufacturing, first stage is creation of 3D model, and then conversion of that 3D model of gear into the G codes. So because a machine can read only instruction in the form of G codes. And in the you can see that this is a miniature gear. Size of this gear is less than 10 mm. You can see this is a helical gear. This is a helical gear, and this is a bevel gear, and this is a spiral gear. You can say helical bevel gear, and this is a ratchet gear, and this is a multi-step gear. Means this is a gear with hub and bow. So in the wiring process, I have manufactured these gears. And there's no need of any second process as we use in other conventional process, additive manufacturing process. This shows the same images of these gears, so you can easily identify that the profile of these gears is very accurate. I achieved the accurate profile of the gear, and also we can see the this bore of this gear is very accurate. There is no any another benefit of this process is that there is no any word formation, and no need to remove another this any additive manufacturing process. First stage is formation of its base. So in this process, there is no need to format a design, create a base for manufacturing. A single wire is used as a tool, and there is no contact between tool and workpiece. As you know, most of you know that EDM process and YDM process. This shows the various steps involved during manufacturing of these gears. So this is a preparation phase in which I prepare the plates and then make a hole, micro hole with the help of a micro EDM. to pass the wire. Then this machining process take place. After manufacturing the ratchet gear by these plates, the next is uh, the metrology phase, means measurement of their accuracy, and energy consumption. This is used to just measure calculate the energy consumption during each gears. And another, I have completed the project on turning by wire additive process. So in this process, I have just created, develop a new rotary table to rotate the hold and rotate the workpiece. This is the titanium bar, which have only 6 mm diameter, and I have performed the turning on both ends of the this bar, and this is a micro turning process because the depth of cut is only 0.2 mm. And this shows the manufacturing take place of titanium. This is there is a lot of there is some research work available on the turning of this bar by wiring process, but they use the belt and DC motor. But I have developed this setup using gear box, and which is attached with the stepper motors, and this stepper motor attached with the controls which compensate the fluctuation in power during machining. And after turning, the next process is surface measurement. So I have used 3D surface LD130 surface reference tester for measurement of surface roughness of this turn bar. And after that surface measurement, the next stage is the measurement of roundness of the turn bar. So this project I did during my project last year. Next, thank you. So you can ask, you have any question? I'm audible?
Hello, Hanji sir.
Yes, sir. If any query, so you can ask.
Audience, any question from your side? Any questions, sir? Have you any query, audience?
Yes, sir. Good evening. Sir, first of
Good
all,
evening,
really
sir.
thankful for the wonderful session. So, sir, my query is, what are the key factors which which influence the cost of additive manufacturing? Is there any factors which can affect? Yeah.
Yes, sir. The first which affect the productivity is the first is a printing speed. So material deposition. So there are a lot of factors which affect your overall, you can say, productivity of this process.
Sir, my query is, how can additive manufacturing be used in industries like aerospace, automotive, and healthcare?
Sir, healthcare, sir, nowadays, people are using gel-based extrusion process for the duct delivery system. Yeah, making capsule for the medical industry, also using for the bone implants by additive manufacturing process. Actually, additive manufacturing is used for the prototype. So this is a developing phase. And also in aerospace is customized product. In aerospace, we have required the lighter materials. So it is very difficult to manufacture products from titanium with other metals. But by nowadays, people are using to manufacture parts by titanium powder. Powder are using to manufacture parts, yeah, components. So we can use additive manufacturing to for the medicals as well as aerospace industry.
Thank you, sir. Any other queries?
Sir, is there is any limitation of the size of the product using the hybrid additive manufacturing process?
Yes, if you need a larger, actually the limitations depend upon the object. No? So for suppose for the larger product, you want to manufacture a larger product, then you need to a larger platform. So which that increase the overall cost. So hybrid manufacturing basically depend upon the specific product. No?
Okay, thanks a lot, sir. Thanks for your reply.
Sir, is there any simulation tools which are helpful in the additive manufacturing which is popularly in use, sir?
Yes, sir, people are using AI and machine learning system to increase the optimize for the optimization process, because any manufacturing process main influence is variable parameters. So if is it necessary to use to suitable parameters, otherwise it affect the overall efficiency of the manufacturing process. So there is a lot of simulating software for the your optimization of the process.
So, which one is most popularly used, sir? And which one we should suggest to the students to apply?
Sir,
Is there any specific one or anyone we can, because you are saying that there is a numerous type of the tools available?
Sir, these a lot of paper mainly people focus on the material characterization. Hardly people focus on the process optimizations. So basically, they if there is a they are using NN methods. Some are using NN methods nowadays. People are using genetic algorithm. Yeah, another methods like machine learning used to improve the optimize the process parameters. So most of people working on just on material characterization one.
Thank you very much, sir. Thank you.
Welcome, sir.
Sir, what are the advantages of using multi-material adaptive manufacturing over the traditional?
Yes, sir. Actually, in traditional, first we need a extra procedure to implement the wire, because in multi-material we need the additional nozzle, yeah, additional wire. So it increase the overall cost. Another thing is the post processing. If there is a different material using it, you need to controlling of temperature. Different material has different physical properties, so it affects the overall quality of the products.
Any query?
Yes, sir, I do have a query. Am I audible?
Yes, sir.
Yeah. So my query is basically regarding selection of this manufacturing process at a single plant, because there are three types of processes like formative, additive, and subtractive. So because they are all
Yeah, actually,
my question is
yes.
basically because they are all advantageous at certain points. So they all of them have their advantages and disadvantages. But the thing is, if we want to select any one method, so generally the one who is going for the formative, he will suggest that formative is better. The one who is taking advantage from this additive, so he will suggest that additive is better. But if you overall compare as a lot size of the manufacturing, like if I want to make a single piece or the multiple pieces or say mass production, taking that into consideration, as well as the cost of overall production. So how you will suggest that we can have a combination of these processes, the setup for the combination that will be workable, or you suggest only the single one to go for?
No, sir. Actually, sir, we can't suggest a single one, sir, because selection of a particular manufacturing process depend upon the applications and materials. Suppose if I want to manufacture gears, gear can be manufactured by subtractive process, also manufactured by casting process, also manufactured by additive manufacturing. But
Yes.
suppose for application, casting product has a less impact strength. So in case of gear used for transmission, so in transmission gear you need a impact strength. So if you need the impact strength, then there is a process of extrusion, because extruded forging product has have a high impact strength. So it's totally depend upon the application and cost. Suppose require gear for the daily needs. Yeah, you can say domestic application. So there is a plastic gear. So plastic gear cannot be manufactured by the if adopted plastic gear by additive manufacturing, it increase the cost, because additive manufacturing is only suitable for the small production prototype. It is not suitable for the mass production. If you are opting for mass production, then there is a better to opt the conventional process. I just like I saw the gear manufactured by EDM and by EDM. These gears have a high dimensional accuracy as well as dean quality, but major problem is that why suitable for the mass production. But in case we need a masterpiece, or if you looking for the masterpiece gear, then we suggest to go for the wire EDM gear, because wire EDM extruded gear has a net near net shape geometry. So it's
Okay,
depend upon yes.
Yeah, that clears some doubt of mine. Thank you so much. But one thing is that if I want to set up at a
Yes.
single place where I'm not getting a single type of orders or single type
Okay.
of say requirement, sometimes it is coming as a single unit, sometimes it is coming as a, let us say 100 units, or sometimes it is required, let us say small pieces, but mass production. So in that case, I think I should have multiple options available with me at a single plant.
Is for first, no, is if you are going to set up any manufacturing plant, you just explore the market demand. No? If you have clear market demand, then focus on the particular that product.
Okay, so you are suggesting that I should go for this market demand first and then focus on one type of particular products that generally, let us say, single or multiple production. So then I should
Yeah.
focus on the single one.
Yes, actually, if you are set up your initially you set up your industry factory now. So if you just install multiple manufacturing setup and you have no order, then you will be in total loss. No? So
Yeah,
first go for the market demands.
Yes. Okay. Thank you so much. So my query is clear. Thank you so much.
Sir,
Thank you.
which type of material is more best than in adaptive manufacturing as compared to all?
These days, mostly people are using thermoplastic, but you know that plastic no, is sometimes we need for metal type, metal is better for the additive manufacturing. But people are actually additive manufacturing is a initially developing phase, so there's a less work, minimum work on metal additive. But people, researchers are focusing on metal additive manufacturing.
Thank you, sir. I think one question in chat box. Any query from participant side? Dr. Harvinder, are you asking in chat box? I think he's asking, can we use the superalloy for adaptive manufacturing?
Superalloy, it possible, but no, it increased the total material cost.
Okay, it will be increase the total cost of.
Yeah, material cost. No, actually, I explained that there is a material limitations because in conventional process there is a lot of option for materials, but in additive manufacturing there is a material limitations. Because if you are going for the superalloy, you need the higher energy and a system to melt that superalloy.
Okay, sir. Thank you.
Metal deposition. Also, another problem is the temperature control. So controlling the temperature is other major problem. So it is possible, but it's need it increase the total overall cost of the additive manufacturing.
Okay, sir. Thank you, sir. Thank you. Any question from your side? Participants, please. I think all queries are handled. One question from.
Is nylon is a good material for additive?
Can we use nylon? Nylon is.
Yeah, nylon can be used mostly, as I mentioned in my slide now. Non-metallic materials, the ABS, nylon. So nylon is depend upon your applications. So material selection basically depend upon your application and parts.
Okay, sir. Any question? Participants, any question from your side? I think no question from. Thank you, sir. It was great session, and I would like to thank for this great session.
Thank you. Can I leave now?
Yes, you can leave. Thank you, sir. Thank you.
Thank you so much for giving me an opportunity to as a guest, as a speaker in this FDP program. Thank you so much.
Thank you, sir. Very, very thank you. Participants, please be on.